Alright, this is the last lesson, lesson 5, and we're going to solve some rational equations. So we're going from expressions to equations. So notice I have some equal signs. I have these terrible fractions that we've been working with. It'll be okay. But this is pulling a lot of the stuff that we've already done together. So we're going to be doing some addition, and I'm going to show you how to solve for a variable. You do not have to worry right now. Actually, I take that back. We are going to check and see if our answer is in the restrictions. And if so, then we throw it out and it's no solution. So let's make a little note to ourselves. If answer is a restricted value, then we have no solution. Also, if you go to plug in your value and the left side doesn't equal the right side, it would be no solution. Sometimes you'll have one answer, sometimes you'll have two. It just depends on, are you going to end up with a quadratic, or are you going to end up with a single variable? How are you going to, what are you going to end up with in order to solve these? So we'll look and see what we've got. Alright, so in this one, I need a common denominator, and looky there, I have one. Even though it's poorly written, I made a mistake. 3m squared, 3m squared, 3m squared, we're doing well. So we're going to take our fractions on the right and combine them into one single fraction. So I'm going to write the left. Here's the denominator of the right, and then I'm going to just put these together. So I'm going to have m minus 4 plus 2, and I can go ahead and simplify that. M minus 4 plus 2 is going to be m minus 2. Alright, now what I'm going to do is I'm going to multiply both sides by 3m squared. You could also use the technique that we did at the very beginning of our class and wrap this in parentheses and cross multiply and cross multiply. You could do that as well. But what we're going to do, actually, no, let's do that. Let's do that. So we're going to multiply this way, and we're going to get 9m squared. And we're going to multiply this way, and we're going to get 3m squared times m minus 2. And then I'm going to need to distribute that. So I get 3m cubed minus 6m squared equals 9m squared. And then we're going to want to get everything over to the same side, so I'm going to subtract 9m squared. So I get 0 equals 3m cubed minus 15m squared. Now, I'm going to think about, and again, this goes back to the whole like factoring everything. I think about greatest common factor. I think, well, I can pull out a 3 and I can pull out an m squared. I know it equals 0 right now. So this is going to be m minus 5. And then I figure out, well, what value is going to make this equal 0? M. So m equals 0. And what value makes this equal 0? M equals 5. So I have two answers right now. Now, what I'm going to do is I'm going to go back and check. Well, can I plug in a 0 and be okay in the denominator? I'm not allowed to have 0 in the denominator. So actually what we're going to do is we're going to throw out this answer. The question is, am I allowed to have a 5 in the denominator? Putting a 5 in the denominator isn't going to create a denominator of 0. So m equals 5 is the answer that we are going to keep. And you could plug it in. Let's see. If I have 3 divided by 3 times 5 squared, I get 0.0004. I'm sorry, 0.04. And then if I do 5 minus 4 and divide that by 3 times 5 squared, I get 0.013 repeating. And if I add to that 2, well, I'm just going to add it together, 2 over 3 times 5 squared. And I get, when I put these two together with 5 in the answer, I get 0.04, which those do in fact equal each other, so this is an answer. If I got something and it equals some other number, we would throw this out and it would be no solution. So you can check these just like any other equation. So m equals 5 is our solution to problem number 1. Alright, let's look at problem number 2. Now, we do not have a greatest common factor, but it should be fairly easy to get one. Looks like they all have x squareds, and these are all numbers that I could turn that into a 6 by multiplying by 3. I could turn that into a 6 by multiplying by 2, and that is going to stay a 6. So we're going to end up with 6x squareds in the denominators of all of our fractions. So that stays put. So in order to get this to turn into a 6x squared, I'm going to multiply by 2 over 2. So that means in the numerator I have a 2. To go from 2x squared to 6x squared, I'm going to multiply by 3 over 3. So that means I've got to distribute that 3. So that'll be 3x plus 3 times 3 is 9. Alright, and then we are going to combine my right-hand fractions. So I'm going to have 3x plus 9 minus 1, right? You see that? 9 minus 1. 9 minus 1 is 8. And then we'll do our little cross multiplying thing. So I'll have 2 times 6x squared is 12x squared. And then 6x squared times 3x plus 8. And then I can distribute. So I get 18x cubed plus 48x squared. And I'm going to subtract 12x squared. I'm going to need another sheet of paper. Hang on a second. Not an odd sheet of paper. Here, I'll use this. Alright, so I get, put it up so you guys can see it. 0 equals 18x cubed, I'm subtracting, minus 36x squared, and then I'm going to do a greatest common factor. So I'm going to factor out an 18, because I know 36 is divisible by 18, and I'm also going to factor out an x squared. And I'll have x minus 2. Alright, here x would equal 0 to make, I got into my restricted things. X equals 0, not equals 0. X equals 0 would make this a 0, make the whole thing 0, and here x equals 2. I think my brain just went to the answer, because if I plug in a 0 here and here and here, I'm going to have trouble, right? So it can't be equal to 0. But could I plug in a 2? I sure can. I'd end up with 24s here, here, and here. So x equals 2 is my answer to this equation.